Hi everyone, so this is going to be my bottle flipping experiment. The team members that were included was me, Heather Cross, and Artie Hernandez. He is my boyfriend who volunteered to do the bottle flipping for me. He's better at it than I am. And then I decided to just do kind of like I did the scientific method for this. So my question was, how much water should you place in a bottle to make it perfectly land most of the time? Because I did realize, like, when we were doing the experiment, that, I mean, even if you have the perfect amount of water, like, that doesn't mean that all the conditions are perfect. So that is why most of the time it will land and sometimes it won't land. So my research that I conducted for this experiment was that I read the project sheet / physics explanation that was given to us on Blackboard. So before starting this experiment, I hypothesized that the bottle filled 1/3 of the way would have the highest number of perfect lands compared to the other two amounts, 2/3 full and all the way full, because it has the most room for the water to slosh around in. I remember in high school this phenomenon was very popular among my peers. Whenever they would do it, I noticed that they needed the perfect amount of water to successfully flip the bottle and stick the landing. The amount of water was always about 1/3, so I used my prior knowledge to help me with my hypothesis as well. So for the experiment, for my experiment, here are my videos. So this is round 1 for the bottle filled 1/3 of the way. This is round 2 for the same amount of water, so 1/3 of the way filled. So if you pay attention to the water in the bottle, you can see how the water sloshes around and spreads out in the bottle. This increases its moment of inertia. In turn, the speed of the bottle slows down, and the rotation makes the landing possible. This is round 3 for the bottle filled 1/3 of the way. So again, this trick relies on the conservation of angular momentum. So as long as the water inside the bottle is allowed to spread, the rotation will slow down. This is round 1 for the bottle filled 2/3 of the way. So as you can see, there's not as much room for the water to slosh around and spread out. So that's why sometimes it's more challenging for the bottle to successfully land upright. You'll see in other videos examples of when it does land perfectly, even though it is filled 2/3 of the way. This is round 2 for the bottle filled 2/3 of the way. So as you can see, it landed perfectly one time. This is now round 3 for the bottle filled 2/3 of the way. Now moving on, the bottle filled completely. So this is round 1 for that bottle that's filled completely, so 3/3 filled. This is going to be round 2 for the bottle completely filled. So pretty much because there's no room for the water to move around and spread, the rotational speed of the full bottle doesn't change, so it's almost impossible to land it. And then lastly, here is round 3 for the bottle that is filled all the way. Okay, so let's go back to the data sheet. Let's experiment. So during the videos, you can see me testing my hypothesis. I've recorded my data in the table above. So this table right here. Also, during the experiment, I noticed that some factors affected the outcome of a successful land, such as holding the bottle from the top or neck of the bottle, the momentum/angle of the person who is flipping the bottle. So it's pretty important to get one specific movement down, and then once you do get that movement, it will just be like fake. You'll be able to keep landing it again and again over and over. Also, it's important for the bottle to have a flat bottom. Over time, the bottle became crushed, so I feel like that also affected the outcomes. So analyzing the data I collected shows that the bottle filled 1/3 of the way with water had the most amount of perfect lands with an average of 4 out of 10 lands. The second highest was the bottle filled 2/3 of the way with an average of 1.3 out of 10 lands. Lastly, the full water bottle was in 3rd place with 0 successful lands. Let's fix that. And then in conclusion, this my hypothesis was accepted because the data shows that the bottle filled 1/3 of the way is the best for bottle flipping compared to the other 2 amounts. This is possible because the water sloshes around and spreads out the most in the bottle that is filled 1/3 of the way. This increases the amount of inertia. In turn, the speed of the bottle slows down and the rotation makes the landing possible. The trick relies on the conservation of angular momentum. So as long as the water inside the bottle is allowed to spread, the rotation will slow down and then now the upright bottle will fall with gravity. This results in a perfect landing. And then for communicate the results, by posting the results in the wiki page, I am publishing and communicating my results with everyone. So yeah, again, here is the data table that I collected. For round 1, I got 5, round 2, 4, and then 3, and then the average was 4. For 2/3, the first round I got 0, round 2 I got 3, round 1 I got 1. Round 3 I got 1, and the average was 1.3. I added up 0, 3, and 1, then I divided that by 3 to get the average. And then of course in round 1 I got 0 for the full bottle, round 2 I got 0, and round 3 I got 0 as well with an average of 0. So yeah, that is my bottle flipping experiment. Thank you so much for listening.